Hey everyone, Mr. Fritz here. I want to do a quick video about how to think of these reference angles when we're rotating around the circle, making these angles of rotation. And what I've drawn for you are basically these four different case scenarios you can have with your with your angles. You can have a terminal side of your angle in quadrant 1, you can have a terminal side in quadrant 2, you can have it in quadrant 3 or quadrant 4. All of these are kind of assuming a positive rotation. There's kind of a similar situation if I were to go the other way, but let's just stick with positives for now. And actually, you know what I might do is I might come up with these random degree measures. Let's call this let's call that 45 degrees. Let's call this 110 degrees. Let's call this 200 degrees. Obviously, this isn't quite to scale, but it's a rough estimate. And let's call this 315 degrees. What I want to do when I'm finding the reference angles, let's recall what the reference angle is. It's the acute angle made with the x-axis. So the first thing I might do is let's just visualize what this means. So the acute angle made with the x-axis in my quadrant 1, well, that's going to be just this angle right here. The acute angle made with the x-axis in a second quadrant angle, that's going to be right here. That's the acute angle. Over here in the quadrant 3, that acute angle is going to be right here. And over in quadrant 4, that's going to be right here. It's always the acute angle made with the x-axis. So it's always going to be one of these scenarios. I'm never going to have like a weird reference angle that's attached to the y-axis or anything like that. It's always with the x-axis. So let's go down the line and see if we can't find all of these different reference angles. Let's start off with the 45-degree angle. That one is probably the easiest reference angle to find because the acute angle made with the x-axis is whatever this angle is. So right here, reference angle is 45 degrees. Done. That's it. Over here in quadrant 2, I have to do a little bit of arithmetic to figure out what this reference angle is. And the way that I like to think about it is if I wanted to find out what this angle is, this acute angle, I like to think about it as like how much further do I need to go to hit 180? So we can think about it like this. If I started at 110, how much further do I need to go to hit 180? Well, that's 70 degrees. What's sort of like an algorithmic way or way we can kind of remember that in general? Basically, I'm going to take 180 degrees and subtract whatever my angle is to find my reference angle. So I could have also said 180 minus 110. That gives me 70. All right, and then quadrant 3, I want to find out what this angle is. And again, I'm going to think about like 180 degrees. Remember, 180 degrees is on the x-axis. And if I'm interested in angles made with the x-axis, it would make sense that I'm thinking about my 180-degree benchmark. And I'm thinking about how much further do I need to go to get to 200. It's kind of easy to see at this point. I have to go another 20 degrees. But again, let's come up with kind of an algorithmic way of how to find this out. If I now take my angle and I subtract 180 degrees, that's going to give me my reference angle. So we could see how this works out. 200 minus 180, that's 20. That's my reference angle right there. And finally, for the fourth quadrant, if I'm interested in this acute angle, let's think about where the x-axis is, or the angle that is made on the x-axis over here. That's a 360-degree angle. If I were to go all the way around, and I want to figure out, that would overshoot it if I went all the way around, and I want to figure out how much further back do I need to go to get to this 315 degrees. So, I mean, basically what I'm doing here is I could think 315 plus what gets me here. That would be 45 degrees. But kind of the shorthand way that you can think about it or generalize it is you could say that 360 degrees minus your angle gives you your reference angle. Now, of course, all of this was in degrees. And if you were to convert over to radians, it's pretty analogous. Basically, all of the 180s become pi's, and all of the 360s become 2 pi. So that's how you find your reference angles. So hopefully this helps, and good luck finding your reference angles.